right, Burkhard. Thank you very much for inviting me here to Vianode and talking about battery materials, more specifically anode materials. But before we jump into today's topic, I would like to understand how you found into the field of battery innovation.
Well, first of all, thanks for coming. It's a pleasure to have you here, Simon, today. Well, my way into batteries, I guess I always was interested in sustainability.
Okay.
So, in the sustainability in a wide range of meanings. When I was a teenager, I was very much into third world aid.
Hmm.
And after finishing my business degree in '93, I wrote my thesis about development aid.
Hmm.
And from there on, I started my career with the chemical industry. I started with BASF, and I spent all my life in the chemical industry, in the materials industry, in the process industry. And my first contact with the lithium-ion battery industry was probably 2010, 2011. I had just joined SGL Carbon,
Hmm.
and I was heading a business unit. And a small part in this business unit was anode material. Anode material through the supply chain of Hitachi into Tesla in those days, Panasonic and Tesla
Yeah.
into those in those days. And the next 15 years, 12, 13, 15 years, I've been responsible on and off for business units within the same company in which anode material was always a small part of the business, but a big part of my passion. And then when 2023, I was contacted by Vianode, I was extremely thrilled about it because Vianode combines two passions of mine. One is the passion for sustainability, producing sustainable anode material.
Hmm.
And the second passion is high tech, doing it in a new way, in an innovative way, very much related to high tech. So
Mm.
this is really what thrilled me. In the midterm, or in the meantime, there's a third aspect coming to it, and
Okay.
that's sustainability in terms of resilient supply chains. How important the industry is for the Western world, and that's also a very big passion of mine.
Yeah, and I think we kind of meet on there because this campaign is built to strengthen, to support the build-up of the European battery ecosystem and e-mobility ecosystem as such. And yeah, so let's join forces there and understand more on the key innovation that Vianode provides. So can you outline like what is this high tech that you're delivering?
Well, first of all, I think we're all aware how important electromobility is in terms of energy transition.
Hmm.
Transportation accounts for 20% of global emissions or CO2
Yes.
emissions. And if you look at electromobility, while it's sustainable, it has still some areas with a pretty high CO2 footprint. And the highest CO2 footprint in EV comes from the battery. And here again, the highest CO2 footprint comes from the graphite material.
Mm.
Graphite is, in terms of volume, the largest part of the battery, and in terms of CO2 footprint as well. So 20%
Yeah.
approximately of the CO2 comes from the graphite in the battery.
Mm.
And we developed a proprietary technology to reduce this footprint by 90%.
90.
90% compared to how anode material and graphite has been produced in the last 20 years, maybe anode material and 100 years graphite.
Hmm. So I think you need to elaborate a little bit on that because this is a pretty bold number. Um, and maybe you can give us an overview of what is the standard process, how it's done.
Yeah,
I mean, 90 something
right.
percent of graphite is coming from Asia,
Right.
specifically China right now, and the chemical process they have in place or the physical process, as you want to call it, they have in place in order to synthesize graphite. And then what is the process that you have in place that allows you to save 90%,
Right.
meaning only having 10% emissions?
Yeah, very happy to do so. So roughly 95% of all the graphite being used in the Western world, North America and Europe, comes from Asia.
Hmm.
And then again, more than 90% comes from China. So it's also, when we talk about later about maybe political resilience, it's a big cluster risk that all the material comes from one country.
Hmm.
In terms of process, the process today, the traditional process also being used in China, is the so-called Atchison technology. Huge, and we talk now only about the graphitization step because that is the big CO2 emitting
Hmm.
step. And Atchison furnaces are huge open pit furnaces. They
Hmm.
could be 50, 100 meters long, a lot of material in them, and difficult to control uniform temperature throughout the furnace.
Hmm.
Yeah,
Maybe to give the listeners and our peers a better understanding, like what is this graphitization? Well, how do you make graphite in the first place, like from
Okay.
a conceptual level, so
Well,
that people
yeah,
understand and can compare better?
right. Making graphite is a little bit like baking. You take powder and you take an egg, for example. You take graphite and you take pitch. You anneal it, you melt, you shape it, and then you have to heat it to 3000 C or
Hmm.
above 3000 C. That is the graphitization step, and that can only be done by electrical energy, and that is the CO2, one important CO2
Mm.
emitting
Yeah,
source. So basically, graphitization at 3000 degrees Celsius, and that is done in these huge Atchison furnaces in
gotcha.
China.
Okay, 3,000
3000
Celsius.
degrees Celsius
Yeah, so that is
minimum.
quite high, and
Yes,
that's also why you need electricity for heating, I
right,
guess, in order to build up this amount
right.
of heat, right?
Right,
Hmm.
absolutely. And that
Okay.
is when you get the crystalline structure, which you need to intercalate the ions in the charging
The
discharging
lithium
process.
ions in the
Right,
anode.
right.
Okay,
Yeah.
gotcha. So let's hover back to the innovation.
Let's go back to the innovation. So one thing is this huge, hard to control Atchison furnace, which is open, so you see a lot of steam, fumes, and diffused emissions in the building as well.
Hmm.
We have an enclosed furnace technology. So we have furnaces which are closed, induction furnaces, which require far less energy and in which we can control the temperature extremely well. And
Okay.
maybe more important, we get a uniform temperature distribution within the furnace. So the result of this is that our material in the furnace can be used 100% because it's 100% graphitized to the same degree, to the same quality. That
Hmm.
is not the case in the Atchison furnace. So if you heat a lot of material up to 3000 C, you create a lot of emissions, which in the end cannot be used as material in the battery.
Yeah, because they
So
go out as CO2 and
well,
CO
not only
and
they go out as CO2, but because it's not uniform in a furnace, some
okay,
of the material
okay.
that you get out, particularly at the electrodes, at the sides of the furnace, might not reach the required graphitization degree. So you can't
Okay.
use them for these applications.
So then a sorting, a grading needs to be done later on as well.
Right. And don't get me wrong, it's not like a huge percentage.
Hmm.
But if you talk about high tech, also small or already small percentages make a big difference in the CO2 footprint.
Yeah, but the very important thing here is you mentioned you want to build this in Europe, right? And if you want to build some industry, chemical processing, etc., the requirements and also the public acceptance to be built here are extremely high.
Right.
And so it's important that in terms of emissions, you have a not exceed a certain threshold.
Right.
And with your closed loop process, basically closed loop, I mean 10%,
Yes.
yes, but
Yes.
you also told me, and I saw that you filtering everything out, you're sorting out metals up front even,
Absolutely.
so to
Yes.
not blow them into the air, right?
Yes, 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 that's right. And there's one other aspect when it comes to acceptance, when it comes to sustainability, that is also the offstream
Hmm.
of the production. So I explained we have these enclosed furnaces. Within these enclosed furnaces, we have nearly only material that we process. If you look at the Atchison furnaces, you have the material that you want to process, and you have a lot of what is called packing media. It is coke and different other media, which basically covers the
Hmm.
material, the anode material that you want to graphitize. You cover it with a lot of other material, and you need this material to protect it from oxygen, and you also need it to create the temperatures. The
Hmm.
resistance of this packing media creates a temperature that you need to graphitize the anode material. Yeah?
Okay.
And this packing media is to a certain degree waste after sometimes every run, sometimes after a few runs. So there are two elements to it. You heat up a lot of material that you don't need as graphite material afterwards. And
Hmm.
the second thing is you create a lot of off-stream material.
Hmm. Okay. So that is in terms of the sustainability of the process.
Right.
Understood, like 90%, and assuming that this can also be delivered on scale, but we'll touch on
Right.
this in a second. First off, I want to ask you a critical question. Is the material then also on spec in terms of performance? Because if you want to build this in cars, I mean, the car battery grade is quite high. The safety and performance standards are high. And if we go into, we're in Norway right now, right, into marine, for example,
Yeah.
application, like safety is an even more important aspect. So can you elaborate a little bit on how does this material then function in its later application?
Well, I think I would just give the proof of the quality of our material. We signed a multi-billion-dollar agreement with General Motors.
Hmm.
And the cell partner of General Motors is LG. So LG, one of the leading cell manufacturers in the Western world, General Motors, one of the leading automotive companies in the Western world. They qualified our material. They signed a multi-billion-dollar offtake agreement with Vianode. That is really the proof that our material is top performant. I think what's also important about the quality is that we can tailor our material to the very requirements of the OEM. Take an example. A few years ago, people were talking a lot about range anxiety. So it was all about the capacity of the cell.
Yeah.
The capacity is very much related to the type and the grade of graphite you're using. Today, you don't hear that much about range anymore. You hear a lot about fast charge. Again, fast charge is very much related to the graphite. How you define the graphite, how you tailor the graphite. And that are all possibilities that we have proven. We have different requirements from different customers, and we tailor our material to the very requirements of the application of our customers.
Okay, so it can be kind of a one-size-fits-all solution, but there's also optimization potential still and room to tailor to the specific customer needs.
Absolutely.
Okay, understand. So then the question is, how do you bring this to market now? I just had the opportunity to tour the factory here in Porsgrunn in Norway with you, where you, I think, have the capacity of building like 2 gigawatt-hours a year
Right.
of anode capacity. But I know that you have much bigger plans, like much, much bigger.
Yes.
And maybe you can, guide us along and take us with you. Like, how will this journey now unfold?
Yeah.
And how are you confident that this will succeed?
Yeah. I think to explain this and to explain our confidence, we need to take a look back as well. While we have tremendous opportunities with our sustainability, with our locations, with our customer relationships, with our technologies, there are challenges. We face competition that has been around and technologies that have been around for close to 100 years. We face competition from Asia, from China, that has been supported for more than 20 years and has developed very good products. We have to be honest about this as well. So it is very important when we come to the market that our customers and our financing partners not only see that we produce good material today, which we have proven, but that we have also de-risked our processes in terms of scale-up. And that's why we have to look a little bit back. We started developing our materials in about 2016, so 10 years ago. We had our first lab pilot in 2019.
Yeah.
We had our first industrial pilot, 200 tons, which is about 200 kilowatt hours factory lithium-ion battery equivalent. We had our first industrial pilot already in 2021. And this plant that you saw today, the Via 1 plant with a capacity of 2,000 tons, is the first full-scale production plant and at the same time the most sustainable production plant for anode materials in the world. And here we basically undertake the scaling risks. So what we did from the pilot to here is increasing the capacity and the units in the same rate to the same size as we will have in our large-scale facility in North America. And that takes us to large-scale facility. We are planning to build in North America a facility with a capacity up to 150,000 tons after a few expansions.
So a factor of 75.
75 compared to what we have here in Norway. That's right.
Yeah.
Yes.
But now the critical question, and I think you have an answer to this, at least I saw that, because scaling it's not linear often. But how do you achieve that now? You said like you have the proof here. How will this result like 75-fold
Yes.
increase in capacity without altering the general process anymore? Like how are you able to scale that now?
It is more or less copy print.
Okay.
So what we have is and there are three parts. There's a powder plant where you treat the raw material in the beginning. Then there's a graphitization step that we already talked about.
Yes.
And then there's a powder plant at the end where we coat the material. So the first and the last part are more or less standard, I would call. We improve the technology as well. But the big difference and the big scaling step is really the graphitization. And as I explained, we have the full reactor size here in Naroya in Via 1, and we now copy-paste this to a large-scale facility in North America.
Okay.
There's one important difference. We're going to automate the material transport. So it's going to be higher automized than the plant that we have here.
Yeah, here we saw that, right? We have those batch batches or in those
Right.
containers that are then transferred kind of manually, even though
Yes.
a big batch and big scale already. But I can assume, so to summarize this, you have those reactors that are kind of the core know-how, the core IP of Vianode, and this is the copy paste. So you will have multiple reactors
Yeah.
that then will be connected along those 3 processing steps in an automated manner, and thereby achieving the higher throughput and also then, I guess, the economic viability.
Right. Absolutely. Absolutely.
Hmm.
Maybe one word about the manual parts that we have here that you refer to of the material transfer from one station to the next. There are two reasons for it. One reason is that we spent $200 million in this facility, but
Yeah.
we're still looking at where can we optimize, and that is why we picked an existing building.
Hmm.
So one reason why we have this is the existing building, but the other reason is very important. I strongly believe what is good today will not be good enough tomorrow. One of our
Hmm.
values in Vianode is we keep learning and we challenge the status quo.
Hmm.
And to have flexibility to change individual working stations, we wanted to keep them to a certain degree separate. And
Hmm.
that would not be the case if you had them all linked with automated material transport.
Okay, I understand you. Talking about the economics and to be competitive,
Mhm.
if you look at the global landscapes, there is fierce competition right now, and it's not decided yet that the European battery ecosystem, the battery industry, will really succeed, European driven.
Right,
Certainly, there will be batteries in Europe, but
right,
the question is where they are made and who's delivering the material.
right.
That said, how do you see the market right now and also investment decisions? You're also building a plant, and that is now coming earlier than the Europe one, right? In North America. So maybe we can an honest but also critical reflection on what does it take in order to build business in Europe, and how does it compare to America, North America in this case, and Asia, especially China?
Mhm. Mhm. I think that's a very, very difficult, very important question. And it's actually a topic that I'm pretty much concerned about because I'm
Hmm.
concerned about how do we build and secure industrial jobs in future industries in Europe? Because that is what it's all about. And if we don't succeed here, we're going to lose industrial jobs. We're going to lose the prosperity that we have in the Western world. That's what I really believe in. I mean, that's a broad political statement, but let's go back to what we can do to support it. Again, take a look who succeeded and how did they succeed. Let's
Yes.
let's let's start with China. China started 20 years ago with a
Hmm.
clear determination. We want to build an industry. We want to build an ecosystem. And China succeeded in addressing both the demand and the supply side.
Hmm.
So they forced the industry to use local suppliers. They closed the borders to foreign suppliers. They subsidized very heavily the demand side by subsidizing cars and the supply side by giving incentives for the production.
Hmm.
And we can criticize this a lot, but the fact is they've built a tremendously strong industry. And part
They
is
did,
also,
yes.
to be honest about, the products are good. If you look at the batteries, if you look at the cars, and also if you look at the materials, they succeeded producing very good products.
Hmm.
So I think it's blue-eyed to think today that we can start and compete from scratch without similar means to support the industry.
Hmm.
We were planning our first plant in Europe, and then the IRA came in North America, addressing both the demand and the supply side, very similar to what China did. And that is why we decided we need to build the first plant in North America because we need to have financed. And to finance it, we need to have a very good business case.
Hmm.
And that is something we cannot create in Europe at the moment.
Hmm. Okay, and I think this leads us over to the challenges that we are facing here in Europe. So I ask every participant, every guest of this podcast along this campaign, the same 3 questions in order to really get a multiple perspective on this matter. So asking the first one, what are the challenges that you foresee or that you see Europe struggling with in order to build this industry? Like what are the key points that you would like to mention?
Let me start answering the challenge with answering opportunities or something positive.
Yeah.
5 years ago, 6 years ago, Europe had developed a technology position and knowledge position which was pretty much on par with Asia. Not quite, but pretty much on par. We had the knowledge to build the entire supply chain for electromobility in Europe. America did not.
Hmm.
So companies were planning to build in Europe. Then the regulatory framework changed and made the American market much more attractive.
Mm-hmm.
And many of those companies who had planned to build in Europe went to North America. So this is, I
Yes.
think, the answer to your question. The challenge is really to turn the tide, to create an attractive environment here in Europe for companies to invest. So there must be an incentive that an OEM is prepared to pay higher prices for equipment, for material in Europe, because
Mhm.
that is what's going to be in the beginning. We cannot expect that we can compete from day one with other industries or
Mm.
other countries that have built, had learning curve effect, had scale effects,
Mhm.
and be competitive from day one.
So you see, the first step needed to be done is by political actors that can provide the guardrails, the shields, in order to let this seed grow in Europe. To have, but I think there's another component to it, because that it will only flourish, it will only grow really big if the investors are also
Yes.
attracted. So do you
Yes.
believe that once political signals are set again nationally, but you also mentioned in our discussion prior, right, on a European level, if that is in place, do you
Mhm.
think investors will pull in and come back to Europe?
Yeah, I think politicians need to create the framework.
Mhm.
But of course, it needs to be together with the industry
Mhm.
and with the scientific colleagues, with the universities and so on. But at the moment, the companies and science has done a lot in Europe. We now need the political framework
Mhm.
to really get it going. And Europe has done a lot, but what is missing is what I call the teeth. We have the Critical Minerals Act, which requires that critical minerals are coming from Europe. There's a percentage behind it.
Yes.
Graphite is a NATO critical mineral. So we know we need it. We have targets to achieve it. But just because we have a target, we don't get there. If there's not a framework that enables business cases,
Mhm.
and that is what has to be done as the next step. Defining a target is one thing, but now also implementing the supportive measures, that is needed. And I'm strongly convinced at the moment we don't get financing in Europe because there's no business case, but we do get financing for North America because there's a business case. So I'm strongly convinced if we had a good business case in Europe, there
Mhm.
would also be financing in Europe. Yes.
Yeah. So I think we need to to intensify the dialogue between those stakeholders, right? And that's why I'm building this expedition, to really show the competences firsthand
Yeah.
with scientific integrity that we have in Europe, in order to convince participants of the political landscape, or also leaders and decision makers, of course, um, and also investors, to say, like, there is a business case. There's just a couple of levers that need to
Absolutely.
be pulled, and then we're back on track.
Absolutely.
Okay.
Absolutely. I'm fully convinced we have the competences in Europe.
Mm.
If we all work together and have a framework that enables us to implement our technologies, our knowledge as partners in Europe, I'm convinced we can win. And let's remember, we talk about extremely important industries. Maybe let me divert 1 second. In I think it was around 2010. I remember there was a graphic from one of the big consultancies. I can't remember which one it was.
Mhm.
It was a 4-field matrix, and one axis was how fast is an industry expected to grow? And lithium-ion batteries was at the very top, very fast-growing, big market. And the other one was a very important axis. That was the axis, how big is the impact and the interdependence of is this industry for others?
Mhm.
So if we succeed in this one, how important is it for others? And here again, lithium-ion battery industry was very top. We talk about electromobility. We can talk about intermittent energy sources, wind and solar. We need storage capacities. Now we talk about
Yes.
drones. We talk about defense. We talk about home appliances, garden appliances. You need
Batteries are everywhere.
everywhere.
Yeah, they
So
become commodity.
this was at the very, very top. And I
Yeah.
think this is what we need to capture. That is what I believe in.
Yes, and it still is the same, right? Like the importance of batteries, even
Yes.
though the dialogue in Germany has come up with, again, with alternative fuels and blah blah blah. Like, I have an opinion about this, obviously. That we even though this discussion is present sometimes, the matter of fact is there that it will be battery driven.
Absolutely. And I believe it's accelerating, and it's accelerating more than expected. And the reason behind it is we have reached something which I would call like positive tipping point. The
Mhm.
prices of the batteries have come down so far, much further than we expected 6, 7 years ago.
Yes.
5-6 years ago, we were talking about battery and we were talking about fuel cells for EVs. Today, fuel cells are really struggling for EVs, maybe not for large applications,
Yeah, they're
because
too expensive.
battery prices have come down so much and much more
Yeah.
than previously expected.
Yeah. So if batteries are so important, and I think we are both convinced about that,
Yep.
what about the potential in Europe? So where do you see Europe being unique in its competence set that gives you gives you trust and encourages you that we will have the European battery industry succeeding in the near future?
Well, what gives me trust? I think one thing is important. There needs to be a regulatory framework which is supportive. Otherwise, I'm strongly convinced we will not succeed and we will lose one of the core technologies for the future. It will
Okay.
not be happen in Europe. So I think that's a very important prerequisite. What gives me hope is what I see in Vianode and what I see in other companies. We take ideas and we improve them. We come with new technologies. We innovate how processes have been done in the past. We turn them more efficient. We turn them more sustainable. I think this is really a huge opportunity that we have in Europe. Together with a traditional cluster, particularly in the automotive industry. So you have the big clusters around the locations where the OEMs are, and you've got very good relationships between suppliers and the OEMs. I think we've got a network and we've got an ecosystem in which also electromobility and the battery industry can strive.
Okay. So if there's one thing, one advice that you would give, one recommendation to our industry, to politicians, to all stakeholders out there, what would it be?
Well, I already talked about the regulatory framework. So let me pick another one, and that is recycling.
Okay.
Let's look at recycling, because in the beginning we started with how dependent we are with critical minerals from, in our case, China, but you can take other critical minerals, be it cobalt, be it nickel, be it lithium. We are very much dependent on imports. So for me, recycling again has two sustainabilities. One is there's going to be a big wave of batteries coming 2035, 2040, full of valuable materials. So we should recycle. Recycling is one, reuse of course, but recycle the most sustainable way to improve electromobility. The second part is, whatever is in the batteries in Europe is already material in Europe. We already have it here. So let's recycle it, let's reuse it, and let's not ship old batteries to other countries again.
What is actually
so that
happening
we
at the
need to
moment, yes.
what is happening at the moment. And I think that is so bad. We very often are desperate that we depend on imports. And then we have the material
Ship
here
it back
and
because
ship it
it's
back out to
not
get more
economically
desperate.
viable yet,
So
yeah.
I think there's so many good ideas. Let's just put it into action.
Okay. So I think this is a perfect statement for the end. So Burkhard, thank you very much for this conversation. It was a pleasure to be here at Vianode, to learn a lot, and looking forward to have this mission together on bringing the battery industry to Europe.
Great having you, and thank you for your time. Thank you for your interest, and I really would love to make it happen in Europe.
Okay. So
Thank you.
thanks. I think, Burkhard, there is one more thing you wanted to mention. Please feel free to do so.
Yeah, one more thing, because I was talking about the competence that you have in Europe. And I strongly believe the competence of the people. And I find it so motivating to see when I come, for example, in Vianode, if I look at the team in Vianode, how motivated, how passionate the team is, and how we can make things happen and how we do make things happen. And I see this also in other companies in Europe. That is very motivating. And I think that's a big value that we have and a big differentiator why I'm strongly convinced that we can succeed if we have the right regulatory framework.